Hi, my name is Aditya, and in this presentation, I will tell you about what is load balancing and why it is the major issue in cloud computing and the different algorithms used to solve those issues. So, firstly, let's see what is cloud computing. It is one of the next generation of high utility computation softwares that changed the way IT companies used to buy and design the hardwares in recent years, which is around 2015. The increase in web traffic of different services are increasing day by day. Everybody is discussing about load balancing and how to solve the issue of load unbalancing. So we will come to that. So cloud computing, we can say that it's a new technology that uses virtual machines instead of physical machines to host, store, and network the different components. And if you ask me how does it benefit the company in deploying the cloud computing resources, then I can say that the most important aspect would be the cost management. So using cloud infrastructure can reduce the capital cost as organization don't have to spend massive amount of money buying the equipment, and this reduces the investment cost in hardware and you don't have to build large IT teams to handle cloud data centers. So those expenditures are also reduced. The next thing we can say about the characteristics of cloud computing is data and workload mobility. So storing information in cloud means that we can access it from anywhere and with any device. So we just need an internet connection. And the other characteristic of cloud computing is security, also known as business continuity and disaster recovery, BCDR. Companies using cloud-based services can quickly recover their data in event of emergencies such as natural disaster like power outages and automatic shutdown due to updates, etc. Now let's see at the different services provided by the cloud providers. So the first one is infrastructure as service, IaaS. IaaS supplies a virtual server instance and storage as well as a API that lets user migrate workloads to a virtual machine. So users have an allocated storage and they can start, stop, and access the virtual machine from anywhere, and they can store anything inside that without any storage limit, depending on the services and the payment plan you have. The next one is platform as service, also known as PaaS. So in this, the cloud providers host development tools on their infrastructures, and users access these tools over internet using APIs, web portals, or other softwares, for example, gateway software or anything. PaaS is used for general software development, and many PaaS providers host software after it's developed. For example, Amazon AWS was launched first, and after that, the AWS Elastic Beanstalk, which is a platform service, was launched on AWS. And there are other examples like Google App Engine and Salesforce's Lightning platform, etc. Next one is software as a service, also known as SaaS. This is a distribution model that delivers software applications over internet. These are also known as web services. So this include the Microsoft's 365 and Google's Gmail, which is an email service, etc. Now let's see how do we choose the cloud service provider. So the first one, we can say that we can choose on the basis of regions and availability. So the first one is Amazon's AWS, which has 25 geographical regions and has the highest number of locations with number of locations as 218. The next one is Microsoft Azure with 60 regions and on 3 availability zones and has 116 locations, which is less than AWS. And the third competitor we have is Google's GCP, which has 27 regions on 82 availability zones, and it has total of 146 locations. Next, we can choose the cloud service provider on the basis of the compute services they provide. For compute, Amazon's main offering is EC2 instance. So this is tailored with large number of options. It provides related services such as Elastic Beanstalk and app development, and EC2 container service such as Kubernetes and AWS Lambda. And Azure focuses on offering virtual machines with tools such as cloud services and resource manager to help deploy application on cloud. And its called Azure Autoscaling Service, and Azure has its own Kubernetes service, and GCP has a Cloud CDN. Now, if we look at the worldwide market shares of leading cloud infrastructure providers, this is for 2021. Then we can see that the AWS has the highest market share in 2021 with 32%, and Azure has 20%, followed by GCP, which is at 9% out of 100, and Alibaba holds 6% out of 100 shares, and IBM holds 5% out of the total shares. So let's see the importance of a balanced load in cloud. So the first one is resource utilization. So it helps in minimizing uh, utilization of resources. It also reduces response time and processing time of the servers. And the next is the scalability. It increases the scalability options of instances or virtual machines on the cloud. The next is throughput. It also increases the throughput. And the last one is load unbalancing is a multivariant problem that reduces the performance of the computing resources and thereby ultimately reducing the efficiency. This is caused by imbalance due to unequal task assignment. So, for example, if more task is assigned to this server and less task is assigned to this server, then uh, this is underloaded and this is overloaded. So the load balancing is process of redistribution of workload in distributed system like cloud computing, ensuring no computing machine is overloaded or underloaded or ideal. Load balancing also tries to speed up the different parameters like response time, execution time, system stability, and thus improving the performance of cloud. So the question arises, how can we guarantee good quality of service by balancing the load in cloud? So this can be done by transferring the load from overloaded process to underloaded process. So if in case server 1 is not responding, so the all the load can be sent to server 2 and server 3. To provide fastest connectivity for all nodes or devices, we use load balancing algorithms. These algorithms help in scalability, resource utilization, fault tolerance, throughput, etc. The most common load balancing algorithm is round robin. In this, the request is assigned to virtual machine in order. So once the request is assigned to virtual machine, then it is moved to the end of the list. The advantage of virtual round robin algorithm is that it does not require inter-process communication. So the question arises, how do we monitor the status of the server after deploying the load balancer? So the answer is by doing the health checks. So what the health check is basically, we have to install web servers on virtual machines, which can get the response from port 80. So that we can check if the server is responding or not. So the load balancer routes request only to the healthy instances. And if it's unhealthy, it will stop routing request to that instance. These are the example of health checks configuration done on different platforms. This is for Azure, this is for Google, and this is for Amazon. So we have to configure the port number. We have to type the protocol. The interval is the interval after which the instance will be called as unhealthy, and the unhealthy threshold is after how many tries the instance will be called unhealthy. The greatest advantage of cloud computing is that single user machines is transformed into multiple user virtual machines. The cloud service provider plays a crucial role in service delivery to the users, and it is a complex task with given available resources. So the problem with load unbalancing is undesirable event on the CSP side. That this reduces the performance and efficacy of computing resources, and along with the guaranteed quality of service also. So this also degrades the service level agreements between the consumer and the service provider. Thank you.